Hello, thank you for watching this video. So in this video I'll be doing November 2022 question paper mathematics paper 2, and this is question 5, which is trigonometry. So I will be using this thing here, this information here, to try to answer these questions. If they are you're not sure how to do it, I'm sure you can learn it on a textbook, or I'll make a class about where is this thing coming from. So, but I'll be using it in this case. So let's do that. Okay, so question 5. 5.1. Given square root 13 plus sine times sine x plus 3 is equal to 0, which is this, where x is an element of 0 to 90 degrees. Without using a calculator, determine the value of the following. So you are given this thing, this equation here, and you're told that x is in this open interval between 0 and 9. So your x, which is your angle, is on the first quadrant here. That's what they're telling you. So you are given this equation, and then you're told your x is between 0 and 90 degrees. That's what they're telling you. So they want you, without using a calculator, to determine the value of the following. So they want you to find 5.1.1, which is sine 360 plus x. They want you to do this. So what I always advise when you are dealing with this kind of question is just try to draw a rough sketch of this, right? So try to draw a rough sketch of this. Let me clean this and do what I'm suggesting. So what you do first is you solve for your function here, which is your sine x. So your sine x, root 13 sine x is equal to minus 3 divided by root 13 divided by root 13. So we are left with sine x, which is equal to negative 3 over root 13. So we are told that this thing is on the first quadrant. So on the first quadrant, your sine is positive, right? This is what they say, sine is positive on the first quadrant. But it's saying, you're told that this is on the first quadrant. And you're told that as it's on the first quadrant, sine is negative. Your sine is negative, which is not possible, because on the first quadrant, sine is positive. So I would think they made a mistake here, right? I would think they made a mistake. It's either they wanted to make this sign here negative. I'll say they wanted to make this sign here negative. Or this was supposed to be negative. So, and then this one was supposed to be positive. Either this part was negative or this part was negative. So what I'm going to do, for the sake of solving this question, I'll make one of them negative so that this makes sense, because at this point it's not make sure. So transpose this to this side. Now it will become positive. So you have positive 3 over root 13. So you have positive 3 over root 13. So what you have more of a triangle like this, something like this, right? This is your 90, this is your 0, this is 180, this is 270, and this is 360. So you have this thing here, triangle here, and your angle here is x, your angle here. And sine is opposite over hypotenuse, so your opposite side is positive 3, because I've made it positive now. Your hypotenuse is root 13. So what you want to do is also find this side here. What is this? The value of the side here. Then once you have the value of the side, then this triangle is complete. Then you will be able to evaluate whatever function that we're given. So we have hypotenuse, we have this side, we want this side. So let's call it A, this side. So you know that r squared, which is hypotenuse squared, is equal to x squared plus y squared. Your hypotenuse is equal to the root of 13 all squared, which is equal to x all squared, which is your a squared, which is the side, plus your y, which is 3 squared. So what do you have now? You have 13 transpose is equal to a squared plus 9. Transpose the 9. You have 13 minus 9 is equal to a squared, which is a squared is equal to 4. Square root plus or minus, square root plus or minus. Oh, I don't like this. Let me clean this. Say, okay, I have a squared minus 4 is equal to 0. Then factorize the difference of two squares. A, 2 plus minus. A is equal to 2, or A is equal to minus 2. But your A is positive this side, so your X is equal to 2. That's what you should do first. Once you have this complete, then you can go on to evaluate whatever they are giving you. So this is complete. I can clean this board now. Like I said I made a change here so that this makes sense. You can make this one negative or you make that part negative. Otherwise it doesn't make sense as its natural given equation. So but this one equation, it does make sense, especially for this condition given here. Because you can't have, say, this is on the first quadrant and say your sign is negative. No, it's positive. So now we can try to answer the questions using this now. You can also clean this part as well. Because you can clean this part as well because we have found all the information that you needed. Right? So they say 5.1.1. Sine 360 plus x. So when you have this, you ask yourself, which quadrant is this thing? Right? 360 plus x, which means above, angle above 360 plus something. 360 minus is here, 360 plus something is here on the first quadrant, right? How? Actually, this is what I always encourage people that I work with, or students that I work with, that you must always work between, I always encourage them to work for this interval, which is for x is an element of 0 to 360, and not work beyond 360. And not work beyond 360 or below 0. So if it happens that your thing go above 360, subtract it by 360 so that it comes back to this interval. So if it happens that it's below, we are on the negative, it's below 0, it's negative something, add 360 up until it's back to this interval. So I don't like working with values that are above, that go past this interval. 360 plus or 0 minus something. I don't like working with those things, with those values. So if you have a condition like this, subtract 60 up until it appears here. It looks like one of these guys that you have here. So which means you have your sine 360 because it's bigger than it's above this part. So minus 360 plus x. So what do you have? You have sine x, you have sine, this and this goes away, you have sine x, right? So sine x, you look at it on your triangle. Sine x is equal to the opposite side over the hypotenuse side, which is equal to 3 over root 13, which is what you are given. That's how you do this one. 5.1.2. 5.1.2. They want you to find tan x. What is tan x? Tan x is the opposite side, it is the opposite side over the adjacent side. Your opposite side is 3, your adjacent side is 2. So your tan x is equal to 3 over 2. That's what your tan x is. Tan x is equal to 3 over 2. And then continue. Cos 180 plus x, 5.1.3, 5.1.3. Cos 180 plus x. So you can see this angle here is within this boundary because it's here on the third quadrant. Then now, when you're there, first question, where is 180 plus? Where is this thing? It's on the third quadrant, right? Then what is the sign of your cos then? Our cos is negative, so you put a negative cos. So it becomes negative cos x, which is negative of cos x. What is cos x? What is cos x? So negative is there, cos x is this one. Cos x is called adjacent of hypotenuse, which is called 2 over 13. So we have 2 over 13. Therefore, your cos of 180 plus x is equal to negative 2 over 13. That's it. So the negative sign is coming from that. That's how you do this one. Got all your 7 marks. Easy, free stuff. Then you go to the next question, which is 5.2. You need this to be able to do these things. If you don't have this, then you're in trouble. Or you might be in trouble. So determine. 5.2 will read the following. Determine the value of the following expression without using a calculator. So you're given this expression. Cos 90 plus theta all divided by sine theta minus 180 plus 3 sine minus theta. This is what you are given. So first thing that you do is to arrange numbers so that they are on the front. That's what I do first. I don't like them when they are like this. So I say, okay, I have cos 90 plus theta divided by sine minus 180 plus theta plus just 3 sine minus theta. Are you happy with this? No, I'm not happy with this one because I don't have this on my between 0 and 360. Because I have positive 180 minus and positive 180 plus. I don't have minus 180 plus something. So because this one is below, which is below 0, this maximum of yours is below 0. So on the first one, it was above 360. It was above 360. So you subtracted it by 360 until it got back to this interval. But now, this one is below 0. So now you must add 360 to bring it back to this interval. So you must add 360 here. And this one here is also negative, right? Which is also below this side. Add 360 to it as well, so that it comes back to this, to what we know, to what we're accustomed to. So you're going to have cos 90 plus theta all divided by what? Sine negative 180 plus 360, because we don't want this maximum to be negative. We want it to be one of these maximums that we have here. Plus theta plus 3 sine. This one is negative as well, which is below 0. Add 360 to it. 360 minus theta. So this is what we'll have. Once you have this, you can simplify it now. And say I have cos 90 plus theta all divided by sine 180 plus theta plus 3 sine 360 minus theta. So this is what you have. This is, I'm happy to work with this because 90 plus theta is there, 180 plus theta is this one, 360 minus theta is this one. So I have all of my things there. Then I'll be able to work well. So now, ask yourself, where is 90 plus theta? It's on the second quadrant, right? Good, we found it. What is the sign of cos? Our cos is negative. What do you do? Put a negative sign, right? So if your maximum here is 90 or 270 or any value that is along this vertical line, then your function, which is cos, changes to its core function identity, which is sine. So if you have 90 as your maximum, or 270, or anything else variation that you are comfortable working with, then your function will change to its core function identity, which is sine x. Divide by 180 plus, where is it? It's on the third quadrant. What sign is your sine function? It's negative. So what you have negative, negative 1 times, so sine x, the maximum is along this line, it's not vertical, so it remains the same. So sine x plus 3, ask yourself, where is the 60 minus? It's on the fourth quadrant, right? What sign is your sine function? It's negative, so put a negative sign, negative 1 there. Then the function will not change to its co-function, to a co-function identity, because it's not, your maximum is 36, which is along the horizontal, so it remains the same. So sine x, right? So what you have negative 1 on top, negative 1 sine x over negative sine x minus 3 sine x. So negative sine x on top, all over this plus this, negative 4 sine x. This and that goes away. You're left, this and this goes away. On top, you're left with 1, at the bottom, you're left with 4. So that thing is 1 over 4. The simplification of this thing. So you're done with this. Then go to 5.3. So 5.3. Determine the general solution for the following equation. They want you to find the general solution for the following equation. So you have two brackets multiplying each other. So you have A times B equal to 0. What this tells you is that either your A is equal to 0 or your B is equal to 0. So if your A times B is equal to 0, either A is equal to 0 or B is equal to 0. Same thing. If you have two brackets multiplying each other, it's either this one is 0 or that one is 0. Then you can start solving from there. So I'm going to clean the ABs and then try to solve this general solution. So it's either the first bracket, which is cos x plus 2 sine x is equal to 0, or 3 sine 2x minus 1 is equal to 0. This is what that means. The product of this is equal to 0. Either this part is 0 or this part is 0. Then you solve them. So say, okay, 2 sine x is equal to cos x, right? Or 3 sine 2x is equal to 1, right? Then you divide by 2, divide by 2. So we have sine x is equal to 1 over 2 cos x, or divide by 3, divide by 3. So sine 2x is equal to 1 over 3. So you can divide by cos here, cos x, divide by cos x. This and that goes away. So we're left with sine x over cos x is equal to 1, which is this part is also equal to tangent of x is equal to 1. Oh, sorry, 1 over 2, 1 over 2. So you have this part and you have this part. So now what you need to do to find the reference angle of this one. So, or let me just start with one and leave the other. I'm going to start with this one. Let's find the reference angle here. So the reference angle of this thing is going to be the arctan 1 over 2, which is equal to what? Punch that in a calculator. Arctan half. That is, what is it? Actually, this was supposed to be negative. This is supposed to be negative. This was supposed to be negative. Supposed to be negative. Yes. So, arctan of this is what? It's 26.57. That's the reference angle, right? But your solutions lie where your tan is negative. So where is tan negative? Tan is negative here and here. So this is the second quadrant. What is our x there? Our x is equal to what in the second quadrant? It's going to be 180 minus our reference angle, which is 26.57, plus the multiples of our period, plus k 180, where your k is an integer, right? And then the x is equal to 180 minus answer 153.43 plus k 180. You know your k is an integer, right? So this is second quadrant. This is where our solution is. The other solution is where? On the fourth quadrant. What we say on the fourth quadrant? We say x is equal to 360 minus theta. 360 minus theta. What is our theta? Our theta is our reference angle, which is 26.57. 0.57. That's k 180. You know what k is now. So your x is equal to 3. So it's going to be 360 minus our reference angle, which is 333.43 plus k 180. This is the period of what? These are multiples to the period of tan, which means same position over different periods. That's what this means. So we're done with the general solution for tan. So we go to this one. So for this one, we find the reference angle. So the reference angle for this one is going to be arc sine 1 over 3, right? So which will be equal to, punch that in a calculator, arc sine 1 over 3, so it's 19.47. This is your reference angle, this one. So, but it's applied where your sign is positive, which is this quadrant and that quadrant. So what does that mean? Which means now your x is equal to what? Theta, which is our reference angle, which is 19.47, plus k to the 60 for the period of sine. So divided by 2, divided by 2, divided by 2. So x is equal to this divided by 2, which is 9.74 plus k 180. right? And the second one, this was the first quadrant, right? For sine. Then now going to the second quadrant for sine, where sine is positive again. So 2x is equal to 180 minus 19.47 plus k 360. So divide by 2, divide by 2, divide by 2. So x is equal to 180 minus our 19.47, our reference angle, then divide that by 2. So it's 80.2426 plus k 180 degrees. So these are the general solutions. Hope it makes sense. Yeah, because the most important thing is finding the reference angle. Then once you find the reference angle, you look where this thing is positive. You know, positive this and that. And this one you look for is negative. It's negative here and there. Turn. Then do the things. So it looks something like this. Hope it's correct. Let's go to the next question. 5.4. Given the identity, which is the identity is, what is it? Cos x plus y times it's going to be very long, right? So let me just clear this. So we are given the identity cos x plus y times cos x minus y is equal to 1 minus sine squared minus x squared minus sine squared y. So they wanted to prove this identity. So we're going to take this side, which is the left hand side, right? You know your compound angle formulas or expansions. It says that if you have cos x plus y, it's going to be equal to cos x times cos y, right? Then the minus from the back of your thing. Minus what? Minus sine x times sine y. So this is at the back of the formula sheet. So this will be expansion of this using that compound angle expansion formula identity. And then if you have minus, you have plus there, right? So you have these two things multiplying each other. So you have this is the top one, this is the second one. So you have cos x plus y, which is cos x times cos y minus sine x times sine y, right? Times cos x cos y plus sine x sine y. So if you can look at this, you will see that you have difference of two squares here. So you can multiply this straight out, or you can see that this is difference of two squares. You factorize difference of two squares here. So it's more like this and that, which is cos x cos y all squared minus sine x sine y all squared. So this is the difference of this. And then you simplify now. So you have cos squared x cos squared y minus sine squared x times sine squared y, right? So you want this in terms of sine squared. So what do we have here? Here we have 1, y here. So we have 1 minus sine squared x, right? Minus times 1 minus sine squared y minus sine x squared x sine squared y, right? So what do you have? You have, multiply this bracket out, this by that is 1, this by that minus sine squared x, this by that, minus this by that is minus sine squared y, this by that minus sine squared x, this by that plus sine squared x times sine squared y minus this part sine squared x times sine squared y. So this and that goes away. We're left with 1 minus sine squared y minus sine squared x, right? Which is equal to your right hand side. We have proven this identity. So you're done with 5.4.1. So you now are going to 5.4.2. So 5.4.2, determine the value of this thing without using a calculator. So you can say, okay, this part here is cos squared 45, right? Minus sine squared of this. This is 45 minus what? Minus 30 squared. So you can expand this using the compound angle expansion identity. So we say this cos squared 45 minus this thing here. So what do we have? We have sine 45 cos 30 minus sine 30 and cos 45. This is the expansion identity, all squared, right? So just simplify this. So what you have here, you have 1 over root 2 all squared minus, this is 1 over root 2, this is root 3 over 2 minus half root 2 over 2. So what do we have? So we have 1 over 2 all squared here minus this. What is this? This is root 6 over 4, right? Minus root 2 over 4 all squared equal to 1 over 2 minus the square of this thing here. What is the square of this? So this is more like 6 root 6 minus root 2 all over 4, then squared. Then let's expand this part. It's 1 over 2 minus 6. Expanding this, minus 2 root 4 times 3, which is 12, right? Plus 2 all over 16. So what do we have? We have 1 over 2 minus this thing. this is this and that, they make 8 minus 6 root 3 all over 16, right? And then you say, okay, I have 16 here, this goes 8 times, so it's 8 minus 8 minus 6 root 3. Actually, it's not 6 root 3, because this is going to be 2, so it's going to be 4 here. So here I have 4 here. So this and that goes away. We're left with 4 root 3 over 16, which is equal to, what is it equal to? It's equal to root 3 over 4. So says the answer looks something like this. Hope it does make sense. So rewrite, consider the trigonometric expression. So here's the trigonometric expression: 16 sine x times cos cubed x minus 8 sine x cos x. So you're given this trigonometric expression. So 5.1.1, write the expression as a single trigonometric ratio. They want us to write this thing as a single trigonometric ratio. So what are we going to do? We can say, here we have 8 times 2, which is 16, sine x, right, times cos x, times cos squared x. Let me remove this line, so it's going to give us problems. This time, this, minus 4 times 2 sine x cos x, right? So this is 8 times 2, times sine 2x times cos squared x, right? Minus 4 sine, this is sine 2x, like here, sine 2x times cos x. What can we do now? We can take, this as a common factor. So we say, okay, sine 2x, inside we're left with 8 cos squared x minus 4 cos x, right? No, there's no cos x here, because the cos x is swallowed by this thing. So we're left this minus 4. This is what we're left with. Yeah, there's no 4 here, there's no sine x here. And then, of course, the x is part of this. So you're left with just 4 if you're taking this as a common factor. So you can take 4 as a common factor as well. So we have 4 sine 2x times, inside here we'll have 2 cos squared x minus 1. You know what this is. So we have 4 sine 2x times this. This is a double angle identity. So this is cos 2x here, which is equal to 2 times 2 sine 2x cos 2x, right? So this is a double angle identity. So we have 2 sine 4x here. So this is how far I can go. So 5.5.2. For which values of x on the interval 0 to 9 will this have the minimum value, right? So they're asking for what values of x will this. Okay. Let me clean this question, but I'll keep this. So okay. So for which values of x on this interval will this expression have its minimum value? Because the expression that the long one that they give it, we have reduced it, we have simplified it into this one. So they wanted for what values of x on this interval are we going to get a minimum value. So what is the minimum value of this thing? So if you think about the range of this thing, the range of this thing is, so for sine for x, the range would be between -1 and 1. It will be here. But if you're multiplying this by 2, so if you're saying 2 sine for x now, you have 2 here, you have -2 here. So they want to find what will be the value of x that will give us the minimum value, which is 2. But that value of x must be on this interval. So which means now you must have your 2 sine x, sine for x, right, equal to -2, then divided by -2 by 2, actually. So you have sine for x, right, is equal to -1. So what you do now, you find the reference angle, which will be equal to arc sine of this, so you have of 1, which is equal to what? Is equal to 90 degrees, right? So you go to quadrant where your sign is negative. Where is it? It's going to be the third and the fourth. What do you do on the third quadrant? On the third quadrant, you say, okay, on third, your 4x is equal to what? 180 plus 90. And on the fourth quadrant, I'm not going to say plus k36 because I'm not finding a general solution. I want specific values now. 4x equal to 360 minus 90. So you divide by 4, divide by 4, divide by 4, divide by 4. So x is equal to, your x is equal to. So it's 90 plus 180 divided by 4. This is 67.5 here, which falls on our range. But let's check this one. So it's 260 minus 90 divided by 4. 360 minus 90, right, divided by 4, which is like 67.5 as well. So it's obvious that our x value is this one, 67.5. same thing. So that's how you do this thing. And you're done with it.